Hello, Matt here from ChemistryStudent.com. In this video, we're going to look at ionic bonding. We're going to talk about what ionic bonding actually is, how ionic bonds form, factors that determine the strength of an ionic bond, and lattice structures of solid ionic compounds. Before we talk in detail about ionic bonding, there are a few essential ideas you need to be comfortable with. Atoms are made up of protons, neutrons, and electrons. Negatively charged electrons exist in orbitals around a positively charged nucleus. Each orbital around an atom can hold one pair of electrons. Opposite charges attract. A charged particle is high energy and unstable. The closer it gets to an opposite charge, the more stable it becomes. As a result, opposite charges attract and will always try to get as close to each other as possible. The closer they are, the stronger the force of electrostatic attraction and the harder it is to pull them apart. Because of this, the further electrons are from the nucleus of an atom, the higher their energy and the more unstable they become. It is the electrons furthest from the nucleus in an atom that get involved in reactions and bonding between two atoms. These electrons are called the outermost electrons and make up the surface of an atom. Electron configurations show the arrangement of electrons in an atom. They are written in a repeating system: a number, a letter, a number. The first number, the principal quantum number, shows the energy level an electron is in. The letter, the type of orbital shape an electron is in, and the final number, the number of electrons in that orbital shape at that energy level. Recap done? Let's go! Atoms can lose or gain electrons in chemical reactions to form charged ions. An ion is just an atom or molecule that has an overall charge. If an atom gains electrons, it will have more negatively charged electrons than positively charged protons, and this will mean it has an overall negative charge. We say it is a negatively charged ion called an anion. Equally, if an atom loses electrons, it will have more positively charged protons than negatively charged electrons. And this will mean it has an overall positive charge, a positively charged ion called a cation. Usually, atoms lose or gain electrons to get a more stable electronic configuration. For example, an atom of sodium has one electron in its outer shell. To get a full outer shell and stable configuration of 1s2, 2s2, 2p6, it will lose this outer electron. Before it loses the electron, it has 11 protons in its nucleus, an atomic number of 11, and 11 electrons. No overall charge, as the total charge from the nucleus, 11 plus, is cancelled out by the total negative charge, 11 minus, from the electrons. After it has lost an electron, it still has 11 protons in the nucleus, 11 plus charge, and now has 10 electrons, 10 minus charge. This means there is an overall charge of 1 plus. The neutral sodium atom has become a positively charged sodium ion. An atom of chlorine has 7 electrons in its outer shell. To get a full outer shell and stable configuration of 1s2, 2s2, 2p6, 3s2, 3p6, it will gain 1 electron. Before it gains an electron, it has 17 protons in the nucleus, atomic number of 17, and 17 electrons, no overall charge. After gaining an electron, it has 17 protons in its nucleus and 18 electrons. This means there is an overall charge of 1 minus. The neutral chlorine atom has gained an electron and become a negatively charged chloride ion. Positive charges and negative charges attract. The attraction is referred to as electrostatic. If there is a positively charged ion, cation, and a negatively charged ion, anion, near each other, they will attract and try and get as close to each other as possible, unless they are given enough energy to overcome the attraction, for example by being heated up. Particles with a charge are, when by themselves, high energy. They are more stable when close to particles with an opposite charge. This is a key idea when talking about ionic bonding. Charged particles get lower in energy and more stable when they get closer to an oppositely charged particle. When two oppositely charged ions get close enough to each other, large amounts of energy are needed to separate the ions and overcome the force of electrostatic attraction. We say the ions are ionically bonded and an ionic bond exists between them. The stronger the attraction between the ions, the stronger the ionic bond and the more energy that is needed to break the ions apart. There is a famous law called Coulomb's law that describes how the energies of charged particles changes as they get closer together or further apart. This law often isn't taught at this level in chemistry, although it can be very helpful when looking at ionic bonding. In short, the law shows us that the strength of attraction between two oppositely charged particles is based on two things: the distance between the two particles and the size of charge that each particle has. The shorter the distance between the ions, the stronger the attraction, and the greater the size of charge, the stronger the attraction as well. A sodium ion with an overall charge of 1+, for example, will form a weaker ionic bond with a chloride ion, charge 1-, than an aluminium ion that has an overall charge of 3+. This is because the aluminium ion has a greater charge and there'll be a stronger force of attraction to the chloride ion as a result. A chloride ion will form a stronger ionic bond with a sodium ion than a bromide ion can, as the chloride ion has a smaller ionic radius. This means the distance between the center of the two ions is shorter. Remember, the shorter the distance between two oppositely charged ions, the stronger the attraction between them and the stronger the ionic bond. Key point: the greater the charge of the ion and the smaller its ionic radius, the stronger the ionic bonds it will form with other oppositely charged ions. All of this means that unless given enough energy to overcome the attraction, a group of oppositely charged ions will arrange themselves to minimize the distance between opposite charges and maximize the distance between like charges. This creates a close-packed structure called a lattice. For example, with sodium and chloride ions at room temperature, there is nowhere near enough energy available to simply overcome the attraction between the ions, and they will form a tightly packed structure. The positively charged sodium ions try and get as close to the negatively charged chloride ions as possible and as far away from the other positively charged sodium ions. Regardless of its overall size, the solid formed will always have the same repeating structure and arrangement of ions. To break this structure apart, large amounts of energy will be needed, and this is why ionic compounds generally have high melting and boiling points. So, to summarize, atoms can lose or gain electrons to form charged ions. Oppositely charged ions are electrostatically attracted to each other and can be held together by this attraction. This is referred to as an ionic bond. The closer opposite charged particles are to each other, the more stable they become and the more energy that is required to separate them. The strength of an ionic bond is based on the size and charges of the ions attracted to each other. The smaller the ion and the greater its charge, the stronger the ionic bonds it can form. Solid ionic compounds have lattice structures to help maximize attraction and minimize repulsion between ions in the compound. They have high melting and boiling points due to the strong forces of electrostatic attraction holding the solid together, requiring large amounts of energy to break. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.